Okay, so this is the question 4, right? Problem number C.
Yeah.
Okay, so so you, A and B were no problem.
I got A.
Uh-huh.
I said they were both equal to each other, and they were
Right.
both 30.
Okay.
And then same thing for, and then for B, I said it wasn't Pareto efficient. I said the natural equilibrium was still 30-30, but they could conceivably deviate and be better, but they wouldn't.
I think it is not. You're right. I think it's not Pareto efficient. But let's just check. Let's just do it from the start. So for A, let's go with this. Okay, so U of N and W is N times W, right? And N plus W equals 60. So if it's just yourself alone, say you want to put it, what do you want to make it in terms of your utilities? What are you choosing, do you think? You want to choose, I think if you choose, how did you do it? You did it in terms of N, or?
I just took derivative of both with respect. I took derivative of U with respect to N, and the derivative of U with respect to W.
Oh, I see.
And then found that they equal each other, and then because it was equal to 60, they both had to equal 30.
That's not right. So the way we would have to do is this. The reason is because, say if you did it like this, the idea is you would set these equal to 0.
Right.
But then it would make sense to have W and N both be 0.
Right.
So the way you'd want to set it up is, say that. So you're choosing two things, N and W, but in actuality you're not choosing two things, right?
Right.
In actuality you're just choosing what?
Just choosing the noise.
One, exactly. So because if you choose the noise, then W is going to be what?
Just 60 minus
exactly
noise.
Right. So if I can do it in terms of the noise.
So you just replace W.
Exactly. So then this is going to be 60N minus N squared, right? So how do I find the optimal N for this?
So then you just take the derivative and set that equal to 0.
So the derivative is going to be of this is, what's this?
60 minus 2N.
Right.
And then equals 0, 2N equals 60, and equals 30.
Right. That's what person.
Okay.
Okay.
And then,
Now let's pop it for two people. So now I have person 1's. Now, you want to still do it in terms of noise, right?
Yeah.
So now it'll be dependent, my utility depends on noise, my noise and your noise.
Right.
And so how will this be? This will be, remember it's N times W.
So the
N equals what?
N equals N1 plus N2.
Exactly. So this is going to be N1 plus N2.
Times the W, which we said was 60 minus N.
Yeah, in this case N1 because it's Y.
Right.
Exactly. Okay, good. So
once you FOIL it out.
Yeah. So now I'm going to, you want to FOIL it? Okay, so this is going to be what? 60 N1, right? 60 N, oh, I'm not doing the FOIL. Outside is what? Minus N1 squared. Right. Then inside is plus 60 N2, right? And then minus N1 N2. Okay. Now to find my optimal, so on person 1 I'm choosing N1, right?
Right.
So I find the optimal N1, so I take what?
Take the derivative.
Okay, yeah. Respect to N1, right?
Right.
This becomes what? With this respect to N1 is 60.
Plus 2N, or was that minus 2N1?
Yeah, minus 2N1, exactly. And then this is like a constant. Yeah, so this is like a constant. There's no N1 in here, so that's like a 0.
Okay.
Makes sense? The derivative of that is 0.
Okay.
And then this is going to be what?
N2.
Right, okay. Set it equals to 0. I solve for N1.
Right.
So I get 60 minus N2 plus 2N1.
So N1 would be 30 minus 1/2 N2.
Yeah, exactly.
And then you do the same thing with respect to N2.
Absolutely. Right.
Okay, so it's just like what we had done in class.
Right, exactly.
Okay, so I'll have to redo that and figure that out. But then, I guess I just don't understand how to introduce.
Okay, let's do that.
The M.
So how we're doing it for this N people. So now we have U1 is going to depend on N1, N2, everyone, N. So, but what is it going to be? It's going to be, again, it's just simply N times W, right? So N is now going to be what?
Just N1 plus N2
yeah, exactly.
plus N2.
Everyone, exactly. That's my N. And then what's my W is going to be?
Just 60 minus N1.
Yeah, okay, it's not a big deal.
Now,
do I want to, I can multiply all this out, do you want to? I guess I can, right? This becomes what? 60 N1 plus 60 N2, right? Plus blah blah blah. 60 NM, right?
Right.
And it's like minus N1 squared, minus N1 N2, minus blah blah blah. So N1 NM. Okay. Now, how do I find the optimal n1. So I'm choosing n1 here, right? On person 1.
Right.
And so my optimal n1 is, how do I do it? Take the derivative with respect to n1, right? What is that? So what's the derivative of this with respect to n1?
Just 60.
Right. So the derivative of this with respect to n1?
0.
Right, so these are all zeros, right?
Right, okay.
So what's the derivative of this with respect to n1?
2n, minus 2n.
Yeah, minus 2n1. The derivative of this?
n2.
Yeah. And there'll be a bunch of things like e minus n3, etc. Right? These are all.
Right.
It'll become blah 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 all the way to nm. Okay, so this becomes 0. Right? So it equals 0. Now we solve for n1. Right? Is that right?
So it'd just be 30 minus 1/2.
Yeah. Okay. Yeah. I'll just.
Yeah.
Oh, okay. Yeah.
60 minus n2, n3, and
Yeah, exactly.
equals 2n1.
And then you divide by exactly 30 minus. If I do this 1/2, it'll be. Then I'm gonna 2 plus.
Plus all the way to n.
Yeah. Right.
Right.
Okay. So I could do the same thing with all the other ones, but I think there's a little bit of a simplification. Yeah, there's a Nash equilibrium in which everyone cheers an identical amount. Okay.
Okay.
So we're going to assume now straight out of it says we're going to look for the one which is identical. So we'll assume that everyone has the same n1.
Right.
Okay. So say let's let it just simply be x. Okay. So if n1 is x and all the other ones are x, so in other words, say that everyone is just the same.
Right.
So what do I put in here? I can get what? 30 minus 1/2 x plus blah, blah, all these x's. Yeah?
Yeah.
Equals x. Okay, so this is 30 minus, now how many x's are in here?
However many fans there are.
Yeah, well it goes from 2 to m, right?
Right.
So I think it's n minus 1, right? If it went from 1 to m, then it would be m of them, right?
Right.
But there's 1 just taken away.
Right.
So there's going to be m minus 1 of these in here.
Okay, yeah.
That's right. So we have x times n minus 1 equals x. Okay, now let's see. We should be able to get this to work, I hope. That's right. We'll see if it wants to. Sometimes makes me think. Okay, I think this is okay. Okay, alright, so now we can solve for x, I think, right? We have 30 equals to x plus 1/2 x m minus 1. Okay, so this is x plus m over 2x minus 1/2 x. I'll just bring my half x inside here.
Right.
X plus minus 1/2 x is 1/2 of x. Let's see if I can show it up here. Okay. So then this is equal to, I think it's going to work, x times 1/2 plus m over 2. And this is 30 on this side. Right? So then I get, so make everything multiplied by 2, get 60 equals x times, this is just 1 plus m. Right, I multiply this by 2.
Yeah.
So then x I think is just 60 over 1 plus m. Okay, so this is my x, so so n1 equals n2, all these things is 60 over 1 plus m. Now let's just check. If n were 1, what's this number?
30.
Right, and I think that's what we got when we first did it, right? If there's one person, it's just 30. And I think if m is 2, you'll find it's going to be 20.
Right.
I think that's what you end up getting from here.
Okay.
Yeah, so I think this is okay. So that's what it is.
So that's just.
Oh, okay. Does the total amount of cheering approach 60 as m increases? That's interesting.
Well, no.
Okay.
Because as m increases, it's getting.
Yeah, no, that's exactly. Each person is cheering less.
Yeah.
But there are also more people.
Oh, but the total.
Exactly,
the total
right.
cheering.
Right.
So the total cheering would.
Okay, let's see. How many? So if there's n people, they're all cheering this amount, 60 over 1.
Yeah, because n is the amount of individual cheering.
Exactly, right.
So as it gets smaller, each person's cheering that amount.
Right.
Which means that as it gets to 60, it is approaching
exactly.
60.
There's n people who
Right.
each one is choosing to cheer
cheer
this
that
amount.
much.
So the total amount of cheering is this amount
Right.
times what? there's n people, each one
times
n.
n.
Right, exactly. N,
Right,
right?
yeah.
N. So does this? So this is the total amount of sharing. As n gets big, what happens to this number?
That number gets smaller.
Or
Or we'll times m.
Yeah.
We'll make it approach 60.
Yeah, exactly. This is 60 over n. 60 times n plus.
Yeah.
60 times n over n plus 1. As n gets large, this becomes close to 1.
Right.
So this becomes 60. Yeah, so this goes
Okay.
to 60. Yeah, so it does. Yeah.
Okay. So that makes sense.
Yeah.
I think I had one other quick question. For 2B,
Okay.
when I kind of did it out, I just got the new utility. The first one I got was they're both like 16. The square root is 16 times a1 or a2 minus.
Okay, let's just check it out. Let's see. This looks good. 16. So this is the derivative, right?
Yeah.
The square, then this is good. This minus 1. 2. Looks good. Looks good. Yeah, that's good. Okay, and then this is like what we did in class, sort of similar, right?
And because they're both the same, it'd just be.
Oh yeah. Okay, sure.
Because I didn't know if I should show out all the other work.
No, I think it's fine.
Okay. And then.
So yeah, 4 over. Let me see. So it's going to be like, yeah, a1 is 42 squares. It's like 4 over 8 squared. So 4 over 64 is 116. Yeah, so this is okay. Yeah.
Okay.
So your question is when 102's changes, right? Yeah.
Yeah. So when it changes, I mean, the only thing that changes would be instead of the square root of 16a, it's 48a.
Oh yeah, sure. You can. I mean, yeah, exactly. You could just do out this whole thing again.
Yeah.
But you can just sort of realize, yeah.
So then the question was, how does the Nash equilibrium change? I just put it changes by rad 3.
Oh no, that's a little different. So look.
Okay.
So look. So before you had a1 equals square root of 16a2 minus a2.
Right.
And a2 equals square root of 16a1 minus a1. And then you're able to solve this to get a1 equals 4 and a2 equals 4.
Oh, am I supposed to?
You have to solve it.
I'm supposed to solve it again.
Exactly.
But the only
right.
equation that changes is a2.
Absolutely, exactly.
So I just set those equal to each other.
Exactly right.
Okay.
So now in the new situation you have, well, you don't have, okay, now you have this. This is the same as before, but now a2 is different.
It's 48, square root of 48,
Exactly.
a1 minus a1.
So now you have to solve these.
Okay.
Now I think how would you do that? The easiest way by far is to do this. You bring this on this side, you have a1 plus a2 equals square root of 16a2, like this. I mean, so over here you have a1 plus a2 equals square root of 48 a1.
And then set those equal to
Exactly right. So a1 and a2 are not necessarily the same.
Okay.
But they'll closer.
Okay.
You can kind of work it out, I think.
Okay. I understand that.
Yeah.
I think those are all the questions I had.
Okay.
We'll just go finish up the homework.
Right, fantastic.
Yeah.
Yeah.
All right. Thank you, Professor.
Sure, no problem.
Really appreciate it.
No problem.
And I'll see you in class tomorrow.
So what's your name again, sir?
Josh.
Josh, okay, good. All right, nice talking to you.
Thank you very much.
Yeah, sure. See you later.
Bye.